Hello everyone. Now we have to discuss the time domain analysis of first order RL and RC circuits. So, this is the last topic in the first unit, that is DC circuits. So, what is time domain analysis in case of RL and RC circuits? That is, when a circuit is switched from one condition to another condition, either by change in the applied voltage or change in any element, then there is a transient period occurs. Means what? There is a change in the time. So, by changing the values of applied voltage or any element, whether it is resistance, inductance and capacitance, we will get a transition period. Means what? We will get a change in current, change in time. So, during the period, the currents and voltages changes from one value to another value. That is, there is a change in the values of current and voltages from previous values to new values, and this period is called transient period. That is nothing but the state is nothing but transient state. So, after this state, the circuit is entering into what? Steady state. So, after at some instance of time, the current or voltages is constant, is maintained as constant. So, means the circuit is entering into what? Steady state condition. So, by reading this statement, that is, when a circuit is switched from one condition to another condition, either by changing the applied voltage or change in any element, whether it is resistance, inductance and capacitance, we are going to get the transition period. During that period, the currents and voltages are changes from previous values to new values. So, this state is nothing but transient state. So, after some time we will get some derivations with respect to RL circuit and RC circuit. So, with respect to the derivations, you will have better idea of this statement. Regarding the statement, you will have a better idea. Okay? Then, in a series RL and RC circuits, the application of KVL to a circuit containing energy storage elements means what? L and C, inductance and capacitance, results in a differential equations which are solved by following methods. So, means what? For example, in case of inductor, the voltage is nothing but L into dI by dt. In case of capacitance, the current is what? C into dV by dt. No? So, these two are energy storage elements, but the corresponding voltage in case of inductance, the corresponding current in case of capacitance is consisting of differential terms of current, differential terms of voltages. That is the meaning of this. Okay. So, this if the equations are in the form of differential equations, we are going to get the two solutions, that is non-homogeneous differential equation, homogeneous differential equation. So, the non-homogeneous differential equation is in the form of dy by dx plus ax plus b. If the equation is same as like in this equation is called as non-homogeneous equation. So, then the solution, the required value of voltage or current should be equals to complementary function plus particular integral. So, this is the mathematical approach. So, in order to get the solution, we have to calculate complementary function and particular integral. So, if the equation is in the form of homogeneous form only, that is dy by dx plus ax is equals to 0, we are not going to get any constant b. If it is equals to 0, then the solution is only for the calculation of complementary function. If it is non-homogeneous equation, that is complementary function plus particular integral. Otherwise, we have to calculate the complementary function for the homogeneous differential equations. So, here CF is nothing but complementary function, which is in the form of some constant into e power minus ax. Here a is nothing but the term here. Okay. Like this, the particular integral is nothing but e power minus ax integral b into e power ax dx. So, like this we have to get the solution. Okay. Now, we have to discuss the initial conditions. So, the initial conditions are required to calculate the arbitrary constant that shows up in general solution of a differential equations. So, what is the general solution? is equals to what? Complementary function plus particular integral in the case of non-homogeneous. If it is complementary function is for homogeneous, this is for non-homogeneous, this is for homogeneous. But in case of complementary function, what is the term? E power minus a x, no? K into e power minus a x. So, this k is nothing but arbitrary constant. In order to calculate the arbitrary constants in this general solutions, we have to need the initial conditions. We have to go for initial conditions. Okay. So, initial condition in case of inductor at t is equals to 0 and I is equals to 0, it acts as what? Open circuited. In the initial process itself, we have concluded these statements, right. If you have any doubt, go through that notes. Okay. In case of inductor, if t is equals to 0, I is equals to 0, it acts as what? Open circuited, means inductor does not allow sudden changes in current, right. If it is in the case of capacitor, if t is equals to 0, V is equals to 0, it acts as what? Short circuited, means what? The capacitor does not allow sudden changes in voltages. So, these initial conditions are required to calculate these arbitrary constants in general solution. So, in case of inductor, when t is equals to 0 and I is equals to 0, the capacitor inductor acts as open circuited, means what? It does not allow sudden changes in current. If it is in the case of capacitor, when t is equals to 0 and V is equals to 0, it acts as short circuited, means what? It does not allow sudden changes in voltages. These initial conditions are required to calculate these arbitrary constants in case of the derivations of RL and RC circuits.